Hey everyone, this is Matt Sky Channel here, and today we're going to be understanding how to do curve sketching. And it's sort of self-explanatory, I guess. It's talking about how with certain information you're able to help draw out a function. Okay, um, so for curve sketching, you have like these stationary points. As we went back to, so for example, in a quadratic x squared, at the origin, that's a turning point because it goes decreasing and back to increasing. Um, a stationary point is like, for example, in the function x cubed, where that's a stationary point where the gradient approaches and then comes out the other way. Um, so like here in the diagram on the right, so we have like turning points there, and the stationary point inflection. And the graph here, all these pictures are from the Jacaranda 6th edition, I believe, for Victorian curriculum. Certificate of Education. Jacaranda for 2019, 2023 study design, I believe. Yeah, so this will be the images I'll be using. Here you can see, so the top row, this is stationary points. So you get maximum, your minimum. So your minimum and your maximum and your stationary point here. So it's what's talking about the x squared and the x cubed. And the bottom row talking about the slopes and the tangents. So like what's the steepness of it. So whether it's negative or positive. And yeah. So one of the things we recall from differentiation is that at a stationary point of f of x, the derivative of the function f dash of x will equal to 0. Yeah. So the example here, determine the stationary points of the function 2 plus 4x minus 2x squared minus x cubed and justify their nature. So there's two parts of this. So first of all, you derive f of x, so you get 4 plus 4x minus 3x squared. And you find the x-intercepts. So here, after doing the algebra, you get 2 minus 3x and 2 plus x. And you get x equals 2 over 3, or x equals minus 2. You find the coordinates of that. So you go to f, the function f of negative 2, which is 6, and f of 2 over 3, which is 94 over 27. Those are coordinates. And if you go, you see here on the picture on the right, so you see that at x is minus 2, f dash x is 0, and the slope is a horizontal line. So what you do is you take points of the function in between, so you have here 1 point after the x-intercept, 1 point after the x-intercept, so you have negative 3 and 1, and 0 is a point in between. And then from there you work out the slope. So x equals negative 3, the gradient is negative 11, so it's a negative gradient. And here it gives you an idea of what the graph looks like. So it's going to be kind of like a super graph here. So gradient stops. I'm not sure if you can do my mouse, but it stops, goes back up, stops, and goes back down. So these are the general steps of how to sketch curves. You find f of 0, so that's like the y intercept. You find f of x equals 0, so find the x-intercepts here. Solve for h dash of x equals 0. So that helps find the stationary or turning points of the function. You then identify the nature of turning points using this sort of step here, taking points in between x-intercepts and, excuse me. So anyway, you find the endpoints if you need to. You find the endpoints because some functions will be restricted over a certain domain. And you find the key features if the question asks you to. And I assume when asked for key features, it could be something like asymptotes and that sort of thing, or where points are discontinuous. So the next part here is strictly increasing and decreasing. Sorry, this is a picture from the textbook. So it says, this is a little confusing, but it says a function is strictly increasing on an interval x subset of between a and b both included, if for every value in that interval f of b is greater than f of a. And then the opposite is true. Similarly, if a function is strictly decreasing of interval x, a subset of a and b, if for every value in that interval f of b is less than f of a. So what's the best way to describe this? So you have like when you have a function, okay, like here for example, here this image at the bottom. Let's say for example, the function is strictly increasing from points B to C, and strictly decreasing from C to E. I mean that's not true actually, but it's actually say strictly increasing, it'll be between D and A and between B and C, and it's strictly decreasing between A and B and C and E. I hope that sort of makes sense. It's just asking for when the function has an increasing or decreasing gradient. The last point here we'll go through is local and absolute maxima and minima. It's kind of really weird terminology, but it's just talking about the types of turning points here. So, for example, you have D and E are both endpoints here because the end of the function. A and B are what's called local. So A is a local maxima, as in this region. It is the biggest, it is the highest, has the greatest y value, and B is the local minima because it is the lowest y value in this region. But what you can discover is that absolute, so it would be C is the absolute maxima. That's the absolute highest y value in the function, and E is, well, an endpoint. It's also the absolute minima. It's also the lowest endpoint. And yeah, that'll be all.